Good morning, everybody. I hope you had a good weekend. Today we are going to finish up this section 4C, properties of logarithms. So on Friday, we looked at these three properties of logarithms, and this is what we're going to be using today. There are ways to rewrite logarithms, either to expand or make it bigger, or condense to make it smaller. So let's take a look at these three properties again, because this is what we're going to be using today. We're just going to be using more than one property at once. So our three properties, our first one is if we have log base b of m times n, so if these are multiplied, we can rewrite it as two separate logarithms, log base b of m plus log base b of n. Our second property, if we have log base b of m divided by n, so a single logarithm where the two expressions are divided, we can rewrite that with subtraction. Log base b of m minus log base b of n. And our third property, if we have a constant in the front, c times log base b of m equals log base b of m to the c power. So we can rewrite a constant that's multiplied by a logarithm into the exponent. So those are the three properties we're going to use today. Some other information we're going to use, just a little reminder on some basic algebra that we're going to be using. When we have a radical, it can always be rewritten as an exponent and vice versa. So this is just a little reminder. If we have the b root of x to the a power, anytime we have a radical, so the b is like whether it's a square root, a cube root, a fourth root, etc. I can rewrite this as a exponent, and it'll be a fraction. This is going to equal x to the a over b power. So the power, the a, stays the same in the numerator. The type of root becomes the denominator. And then the same thing works in reverse here. If we have x to the a over b power, that can be rewritten as a b root of x to the a power. Okay, a few examples. Most often we see this written as a radical, and we have to rewrite it as an exponent. So a couple examples, if we have a square root of x, a square root would be an index of 2. So this would be x to the 1 over 2 power. There's not a power there. This is just like x to the first power. Or if we have a cube root of x, that would be like x to the 1/3 power. If I have a fourth root of x, that would be x to the 1/4 power, etc. Now, say we have something like the fourth root of x cubed, we can rewrite that as x to the 3/4 power. Okay, so that's what this property is telling us. That's something we already know from Algebra 2. So let's do a few this way as well. If we see exponents that are written as fractions, we can rewrite them as radicals. So for example, if we see x to the 2/3 power, I can rewrite that as cube root. The 3, the bottom is the type of root, so this would be a cube root of x squared. Or if we have something like x to the 6/5 power, the 5, the denominator is going to be the type of root, so this would be a fifth root of x to the 6th power. The denominator still stays the power. So we're going to be using that today when we're expanding or condensing. So let's get on to some examples here. So let's look at number 15. The instructions say, apply properties of logarithms to rewrite the following expressions as a single logarithm or number. So what that means, since we're trying to rewrite it as a single logarithm, is we are trying to condense. So condense means make it smaller. So our final answer should only have one logarithm. So if we look at A, we have 2 logarithms. we have 1/2 log base 3 of 25 plus log base 3 of 4. So there's two separate logarithms. We want to write those as one logarithm. Then on B, we also have two logarithms, and on C, we have three logarithms that we are going to rewrite. So we're trying to rewrite this as one single logarithm. Okay, so when we're condensing, we're using our properties of logarithms. I do see a plus sign in between here, so I am going to need to put these two together as one logarithm. However, before I can do that, I have to do something with this half in the front. So that's using the third property of logarithms. I think I'll write the three properties up at the top here so that we can reference them as we're doing these examples. We have log base b of m times n equals, so we can rewrite it as log base b of m plus log base b of n. I know I'm going to be using this property because I see a plus sign here. The next property is very similar, but has to do with if we're dividing. So the next property is if we have log base b of m divided by n, can be rewritten as log base b of m minus log base b of n. And then the third property is if we have a constant in the front, c times log base b of m, that constant in the front can move to the exponent. So this is going to be equal to log base b of m to the c power. So we already have those three properties written down. We already used those on Friday, but those are the same three properties we're going to use today. All right, so on 15a, the first thing we're going to do is with this half here, I have to do something with that because if I'm going to combine these into one logarithms, I can't have any constants in front. So that's where I'm going to use this, this third property here. I'll label these so it's easier to talk about which one we're using. So this property, I could take that constant in the front and move it to the exponent. It's only on the front of this logarithm, 1/2 log base 3 of 25. So it's going to move to the exponent of the 25. So this part of it can be rewritten as log base 3 of 25 to the half power. So the half is in the power. Another thing we can do to simplify this is where we had to review those properties of exponents. This half power, remember, means a square root. So this also means log base 3 of square root of 25. So that's what the half power actually means. Because we're doing a square root of a whole number and the 25 is a perfect square, I can simplify that. And square root of 25 simplifies to 3. So after all that, we have log base 3 of 5. That's just what this first part simplifies to. And then we still have the plus log base 3 of 4. Now I can put these two together using property 1. So this looks like this format here, log base b of m plus log base b of n. So when I put them together, since there's a plus sign in between, it's going to be log base b, so it's still going to stay log base 3 of m times n, so 5 times 4. Because those are actual numbers, I can multiply them together. So we end up with log base 3 of 20. So that's our final answer because now it is written as one single logarithm rather than two logarithms. So that's our goal when we're trying to condense. All right, let's look at example B. So this one we're working with a natural logarithm. So that just means they're both a base of e, but that doesn't change anything. So again, we have two separate logarithms here. We have 5 natural log of x, that's one logarithm, minus 3 natural log of x plus 2. So this 5 is in front of this natural log of x, and this 3 is in front of the ln of x plus 2. So both of these, we could use property 3 first, right here. They both have a constant in front. So on the first logarithm, I can move the 5 to the power of the x. So that's going to become natural log of x to the 5th power. And I still have the minus in between. When I'm using this third property, I'm just using the number in front, not the sign. So not the minus sign. So now on this expression here, the 3 is moving to the power of that. So that's going to be minus natural log of x plus 2 to the 3rd power. There's several ways we could write that. You don't really need the parentheses around the x plus 2 cubed, but you do need parentheses around the x plus 2 part. So the x plus 2 has to stay in parentheses, and that part is cubed. Okay, so now we've used one property, property 3. Now we need to use another property. The property I need to use next, I'm trying to condense this into one logarithm. So I've got this minus sign here. So I know I'm using property 2 right here. This one has the minus sign in between. So this right now is in the form log base b of m. So this whole thing is m minus log base b of n. So this whole thing is n. So when I rewrite it, it's going to be in this form, log base b of m divided by n. The m has to come on the top. That's the one that comes first. So when I rewrite it, it's still going to stay the same type of logarithm. So it's going to be a log base e or a natural log. And it's going to be m on the top, so x to the 5th on the top, over n on the bottom, which is x plus 2 cubed on the bottom. Now, if you want, you can have parentheses around the whole thing like this. And this is in the form m over n. And now we have condensed it into one logarithm. So there is our final answer on that one. All right, we've got one more. Now you'll notice on C, this one has 3 logarithms. So we actually have to take 3 logarithms and condense it into one single logarithm. We're just going to go step by step. So we're just going to go in order from left to right when I do this. However, like I did on the first 2 problems, I am going to use property 3 first. So any of these that have an number in the front, a constant in the front, I have to move that to the exponent. So the first logarithm is just log of x. It doesn't have any constant in the front. And we have a plus sign, so plus 2 log of y. This one does have a 2 in front, so this 2 is going to move to that exponent. So this is going to become log of y squared. Okay. And then this one has a 3 in front. So minus 3 log of z. The 3 is going to move to the power of the z. Now, I'm still going to have a minus sign here. So I'm not taking the z. I'm not taking the negative with this. So it's not z to the negative 3 power. I'm only taking the number. I'm just taking the 3. So this would be minus log of z to the 3rd power. Okay. And then this didn't change at all. There's no constant in front. So I still have log of x less this. Okay, so what I've done so far is used property 3 to move the number in front to the exponent. So log of x plus log of y squared minus log of z cubed. So now when I condense, I'm going to just, since I have plus and minus, I'm just going to go in order from left to right. So I'm going to condense these two together first. So these ones have a plus sign in between. So this is in the form, I'm using property 1 here, log base b of m plus log base b of n. So when I put these together, notice this doesn't have a base written. That means the base is 10. So when I rewrite it, it's still a base of 10. So when I rewrite it, this would be log of m times n. So since it's x times y squared, you don't really have to put the dot in between, although you can. This is just log of xy squared. Now we still have this one minus log of z cubed. Now I can put these two together using the second property here with the subtraction. So this one has these two now have a minus sign in between. And so this is log of m. This whole thing is m minus log of n. This whole thing is n. So when I condense these into one logarithm, it's going to be log base b of m divided by n. So it's still just going to say log base 10 or just log. I'm going to have m on the top. The first one has to be on the top. So xy squared on the top. On the bottom, I have n. So I have z cubed on the bottom. And if you want, you can put that whole thing in parentheses. So now this is in the form log base b of m divided by n. So that's what condensing looks like. We're trying to rewrite it as one logarithm. And this is going to be useful when we're trying to solve equations in the next section. And if there is more than one logarithm, we always have to rewrite it first so that there's only one logarithm in our problem. So that's where we'll stop for today. Tomorrow we'll do the last part, which is the opposite of this. So here we were condensing and trying to make it smaller. Tomorrow we will expand and try to make these, rewrite them into bigger forms. All right, everybody, see you later.